Okay, on the 8.2 quick check, we're starting off with here about these half-life graphs. So it says here to label the vertical axis from 0 to 200 and the horizontal axis from 0 to 11 days. So I'm going to take a moment and do that. Okay, now that I've labeled the axes, I'm going to say, okay, I want to go draw the graph for 200 grams of ferronium with a half-life of 3 days. Now again, for these kind of problems, we don't really care what the chemical is, we don't care what kind of decay it is, we're just worrying about the numbers. So 200 grams for 3 days. So we start with 200 grams, okay, and then we say, okay, after 3 days, I'm down to 100 grams. And after another 3 days, 6 days, I'm down to 50 grams. And after another 3 days, 9, I'm down to 25 grams. It's about there. And if we wanted to go on to 12, we could get down to smaller. And then we're just going to connect those. Okay, and that is the half-life graph. Now it continues on and says, okay, let's do it for TM, what is it, tellurium? I don't think what that is. Anyway, we don't care. We had 200 grams with a half-life of 9 days. So a half-life of 9 days would start in the same place, but then after 9 days, we would go down to half as much. So we're going to go to 100 after 9 days, and then we don't have any points, so we're just going to fake this one. Then we'll get a graph that looks something like that. I'm going to try again. Okay, a little bit more of a curve. Now, on a test, you might look at these and say, okay, well, what is the half-life for one of these chemicals? And you say, well, how long does it take to get down to half? So if I started at 200 and got to 100, the amount of time it took here was 3 days, so my half-life is 3 days. In the other one here, if I started with 100 and went down to 100 after 9 days, I knew my half-life is 9 days. So we can work either way on a test. Okay, let's do some problems. Okay, show your work. And it says here, okay, we want to, if the half-life is 3 days, how long will it take for an 80-gram sample to decay to 2.5 grams? So we have two things. We have our time and we have our half-life. And then we have two more things, and that's the mass at time 0, and we have the mass at time t. Okay, so what are we telling? We're saying that we have a half-life of 3 days. And how long will it take for an 80-gram sample to decay to 2.5 grams? So if we know these bottom two numbers, we're looking for the total time. If we know these bottom two numbers, then that means we're going to draw a picture, and we're going to say start at 80, and we're going to go down. How many half-lives do we have to go down until we get to 2.5? So 80 goes to 40, 40 goes to 20, 20 goes to 10, 10 goes to 5, and 5 goes to 2.5. And so I can see that takes 1, 2, 3, 4, 5 half-lives, and each half-life is 3 days, so this is 15 days. Okay, on the next problem, we have the same 4 variables: the time, the half-life, the mass at time 0, and the mass at time t. And so it says, what is the original amount of a sample? So we're looking for mass at time 0. If after 36 days, okay, 0.2 grams remains. So we have 0.2 grams at the end, and the half-life is 9 days. So one of the things we were mentioning before, that if you have these two numbers, then we're going to divide them, and what that for is the number of half-lives. So we have 4 half-lives. So that means that I would go 1, 2, 3. I have 4 half-lives we're talking about. And the 0.2 is what we have at the end. So we have 0.2 grams. So we can work backwards. And so at back one half-life, we would have had 0.4 grams, and we would have had 0.8 grams, 1.6 grams, 3.2 grams. And so that's our answer. We'd have 3.2 grams. So we can do this. And remember, you can also do this mathematically, and if you want to do it mathematically, that's fine. But this is the way I do it, okay, with these little scoopy arrows. Each one represents a half-life. So look for these 4 variables, okay, and then set up your picture, and that'll help you do these problems. Good luck.